expand the expression using the binomial theorem. Okay, binomial theorem. This is an important theorem used in higher math and science. So what is it? Well, it basically says by 2, when you have two things to a big old power, binomial 2, like a bicycle has two tires. So you have two things to a big old power. Is there a way you can jump right to the answer here without having to do all the foiling? You know what I mean? If we took 4x minus 3 to the fifth, that would be 4x minus 3 times 4x minus 3 times 4x minus 3 times 4x minus 3 times 4x minus 3. We'd have to FOIL and then, then FOIL that and blah. It's terrible. It's a ton of work. We don't want to do that. These come up a lot in higher math and science, these kind of questions, two things to a big old power. And we'd like a formula, a theorem, where we could just jump right to the answer without having to do all the foiling. That's what the binomial theorem is. Here's what it is. It says if you have two things, call them x and y, that could be Joe and Tom, A and B, whatever, to some big old power n, and rather than doing n, because I think that might be confusing, let me just make up a number. What if it's 5? I'll just do the number we have here. What if it's 5? How do you do it? What's the plan? Well, what you do is you start with something called 5 choose 0. I'll explain what that is in a minute. For now, it's not a fraction. I'm not missing the bar there. There is no bar between that 5 and 0. They're sort of just hanging vertically above each other with parentheses around it. I'll explain in a minute. And then you take the first item and you put it to the fifth power. And then you go right on down the line. So 5, 1, 5, 2, 5, 3. It's kind of sloppy. 5, 4, and 5, 5. So you see, I'm sure you see the pattern. So whatever power they give you, start with that choose 0. I'm going to be saying the word choose. This is called 5 choose 0, 5 combinations of 0. Either way, it goes by either phrase. 5 choose 0, 5 combinations 0. It's going to be a number in a minute. I'll show you how to calculate it. I'll show you two different ways. It's a number. But anyway, 5 choose 0. So you start whatever number they give you here, you start with that over 0, and then 1, 2, 3, 4, 5, all the way down. And then you start with the first item to the fifth power, again, whatever power here, and then go down 4, 3, 2, 1, 0. And then next to it, you take the second item, y, and you go the opposite way. Start with 0 and go up instead of starting with 5 and going down. 2, 3, 4, and 5. And we're going to add all these things together. That's the formula for how you do it. Now, I've got to show you what those 5, 0, 5, 1, 5, 2 things are, and then I'm going to do this particular example. So first off, let me show you about the 5, 0 kind of stuff. So when you have n choose r, I'm going to give you the general formula. It's always the top number factorial, that means multiplied all the way down to 1, over n minus r, top minus bottom factorial, times the bottom factorial. So let's do these particular cases. So in particular, what is 5 choose 0? In fact, actually, why don't I, that's not very good organization. Here, let me do this. Let me back this up, write the formula up here. In choose r is top number factorial over top minus bottom factorial times bottom factorial. Okay, and then I'll do these here. So I'll go 5, 0. What is 5, 0? It's top number factorial over top minus bottom factorial times bottom factorial. See how I followed this formula right up here, this formula which says top over top minus bottom times bottom factorial. Okay, now what is that? Well, 5 factorial means Well, here, let's keep it this way. 5 minus 0, that's just 5 factorial, 0 factorial. And then what is 5 factorial? It's 5 times 4 times 3 times 2 times 1. Same thing on the bottom. 5 times 4 times 3 times 2 times 1. Now what is, so there's 5 factorial. What is 0 factorial? Well, that's weird. That's 1. Let me just write that right up here. 0 factorial is 1. That seems weird. Like, why shouldn't it be 0? You're right. They made it up. Truthfully, all of math is made up. All of math is made. The binomial theorem is made up to help us deal with things in the real world. Well, they just made this up because it makes things in the real world easier. It makes this formula easier to deal with. So it's just defined. They literally defined it to be 1. They said it will be 1 because we say so. And just because that's what's going to be easiest to deal with formulas in the real world. Okay, so what happens here? All these cancel, which just is 1, isn't it? When the top and the bottom of a fraction cancel, it's just 1. So 5 choose 0 is 1. Let's do the next one. 5 choose 1. So same formula, same plan. Top number factorial over top minus bottom factorial times bottom factorial. That's what the formula says. So that's 5 factorial over, that's 4 factorial, 1 factorial. That exclamation point, you say factorial. And then that means multiply all the way down. 5, 4, 3, 2, 1 over 4, 3, 2, 1 times another 1, right? And then what cancels? Most of the stuff. 4, 3, 2, 1 and 4, 3, 2, 1. So you just get 5 over 1, which is 5. Okay, let's do the next one. 5 choose 2. It's top number factorial over top minus bottom factorial times bottom factorial. So that's 5 factorial over 3 factorial, 2 factorial. And so that's 5, 4, 3, 2, 1. Over 3 factorial is 3, 2, 1, and 2 factorial is 2, 1. Okay, what cancels? 3, 2, 1, 3, 2, 1. We're left with 20 over 2, which is 10. So 5 choose 2 is 10. 5 choose 1 is 5. Okay, we're rolling. Let's keep going. 5 choose 3. Same thing. Top number factorial over top minus bottom factorial times bottom factorial. So that's 5 factorial over 2 factorial, 3 factorial. That's 5, 4, 3, 2, 1 over 2, 1 and 3, 2, 1. Cancel. Most of the stuff usually cancels. 3, 2, 1, 3, 2, 1. We're left with 20 over 2, which is again 10. So 5 choose 3 comes out to just be the number 10. See how these just all become numbers? 2 more to go. 5 choose 4, same formula. Top factorial over top minus bottom factorial times bottom factorial, which is 5 factorial over 1 factorial, 4 factorial. I'm going to show you an easier way in just a second, but some people might like this way better, so I'm showing this way first. 5, 4, 3, 2, 1 over 1 times 4, 3, 2, 1. What cancels? Most of the stuff. 4, 3, 2, 1, 4, 3, 2, 1. We're left with 5 over 1, which is 5. One more. So last one here. 5 choose 5, which is top number factorial over top minus bottom factorial over bottom factorial. So that's 5 factorial over 0 factorial 5 factorial, which is 5, 4, 3, 2, 1 over, now what was 0 factorial? Remember, they defined it. They said, we say so. 0 factorial is 1. So this is 1 times, and then 5 factorial is 5, 4, 3, 2, 1. All right, what becomes of that? 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. When the whole fraction cancels, it's just 1. So 5 choose 5 is 1, 5 choose 4 was 5, etc. So we got all those coefficients. Now, there's a better way, an easier way to get all those coefficients. Let me show you. It's something called Pascal's triangle. It's a beautiful discovery that Pascal made. So basically, here's the deal. If you will just start with a 1 in the middle, and then start making ones go out in a triangular fashion. That's why it's called Pascal's triangle. And just keep going out and down, making ones. Just keep going out and down like this. Now start filling in the inside. How do we fill in the inside? Well, it's what they add to be. So in other words, 1 and 1 add to be 2, of course. And 1 and 2 add to be 3. So you add two numbers and the totals below. 2 and 1 is 3. Just keep adding downwards. 1 and 3 makes 4. 3 and 3 here in the middle makes 6. 3 and 1 makes 4. You good so far? We're just putting ones down the outside and adding the numbers in the middle, adding downward. So let's just put some more ones. Just keep going. We can do this forever. We'll do maybe 2 more rows. So keep adding. 1 and 4 add downward to be 5. 4 and 6 add downward to be 10. 4 and 6 add downward to be 10. 4 and 1 add downward to be 5, not 10. And we got a little adding problem there. Okay, this making sense? Now hold on. Hold on. Does that look familiar? Look at this row. 1, 5, 10, 10, 5, 1. Look back here. 1, 5, 10, 10, 5, 1. That's the same coefficients that we did all this work to get. Look at that. That's these coefficients right here. You could just do, so in other words, a way better way to go is to use Pascal's triangle to say, oh, okay, wait a minute. I've got a fifth power. I got a fifth power right here. I'm just going to go down here, grab the one that has the 5. There's my coefficients, 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Done. Don't need to mess around. What if you have like a sixth power? Well, that's the next row. 1 and 5 makes 6. And then just keep adding, adding downward. 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 1 and 5 is 6. So if you have a sixth power, you use this row. If you have a fourth power, you use this row. If you have a third power, you use that row, etc. You can go down as far as you want. Put that thing right in your notes for the next exam, and you'll have these coefficients. That's not the whole answer. That's the coefficients. All right. So that's these. It's these coefficients, and then you still have the x and the y stuff that comes afterwards. All right. With all that set up, let's do this. Now we're ready after all that theory to do this particular problem. 4x plus negative 3 to the fifth. This is a formula for cranking out two things to a big old power. Binomial two things theorem. All right, 4x plus negative 3 to the fifth. Let's do it. So maybe I'll just come right here. So we have 4x plus negative 3 to the fifth power. How does it work? What I'm saying is you start, first off you grab the fifth power coefficients. Well, they're all right here. I'm not going to need to do anything. It's 1, 5, 10, 10, 5, 1. That's those coefficients. Times, and then each of these is going to multiply by something what? Remember what it is? What's the formula say? You grab the first thing to the fifth power. Whatever comes first to the power they gave you, and then go down 4, 3, 2, 1, 0 for that thing, right? So grab the first thing, that's 4x, but you got to put parentheses around it because you got to do the whole first thing to the fifth power, and then the whole first thing to the fourth, and then the whole first thing to the third, and then the whole first thing to the second, and then the whole first thing to the first, and then the whole first thing to the 0. Is that making sense? And now you grab the second thing, right? Just looking at what this formula says here. The second thing, they called it y here. Have that start with a 0 and go up to 1, 2, 3, 4, 5 for the second item. That's the pattern. That's the binomial theorem. Grab the second thing, got to put parentheses around it, and start with a 0 power. He starts 0, right, and goes up. He goes the opposite direction. He goes up. The other one started at 5 and went down. 2, 3, 4, 5. All right, so we got the coefficients in the front from the Pascal's triangle, and then we had the first term to the fifth power right here, 4, 3, 2, 1, 0. The second thing, start at the 0 power and go up 0, 1, 2, 3, 4, 5. All right, let's do this. Now we just work these out. What am I talking about? Well, what does this equal? This is 1 times, now 4 to the 5th power. Use your calculator. It'll tell you 1,024 times x to the 5th, right? Because 4 is to the 5th and x is to the 5th. Times minus 3 to the 0. That's just 1. Remember, anything to the 0 power is 1. So what does that equal altogether? 1,024 x to the 5th. That's our first term. 1,024 x to the 5th. We've actually got our first term. Let's crank out our second term. So it starts with 5. And then 4 to the 4th. Use your calculator. What's that? 16, 13, 1, 2, 256. X to the 4th, right? Because the x and the 4 are raised to the 4th. And then negative 3 to the 1. That's negative 3. So this one's going to come out negative, isn't it? Because we have a negative sign in there. Multiply 5 times 256 times negative 3. And I'm getting negative 3840. X to the 4th. So do you see how that worked? See how I was able to get that one? So now let's do the next term. It's going to be 10 times 4 to the 3rd. Use your calculator. 64x to the 3rd, because the 4 and the x are raised to the 3rd. Negative 3 to the 2nd, that's positive 9, isn't it? Multiply 10 times 64 times 9 on your calculator. So it's 90 times 64. 5760, I'm getting positive 5760 x to the 3rd. That's our third term. Next one, 10 times 4 squared is 16x squared, right? Because the 4 and the x are squared. Negative 3 to the 3rd, that's going to be negative 27. 3 times 3 is 9 times 3 is 27. It's negative because there's 3 negatives. So now multiply 10 times 16 times negative 27 on your calculator. It's coming out negative 4320 x squared. You imagine all the work it would have taken to do this by hand. Next one, multiply 5 times 4x. That's just to the first. And negative 3 to the 4th. Use your calculator. 3 to the 4th is 81. It's positive because 4 negatives is positive. So now multiply 5 times 81 in your calculator. Positive 405. Oh, wait, I forgot the 4 here. 5 times 4 times 81. Let me try. That'd be 1620. Positive 1620 x, and then one more term. 1 times 4x to the 0. What's anything to the 0 power? 1. That whole thing to the 0 power is 1. Negative 3 to the 5th, use your calculator. It'll be negative because there's 5 negative signs. 3 to the 5th, 243. So 1 times negative 243, that's easy. Negative 243. So that means the binomial theorem, which was 4x minus 3 to the 5th power, what does it equal when all is said and done? 1024 x to the 5th, right there, minus 3840 x to the 4th, right there, plus 5760 x to the 3rd, minus 4320x squared plus 1620x minus 243. There's the final. We jumped right to the answer. I mean, we had to do a little bit of work, but only this, way better than trying to FOIL this thing out 5 times. And this will work just as easily if you have a 10th power or 20th power. It's a formula for 2 things to a big old power. There it is. That's the pattern of the binomial theorem and how it works.